Hello everyone, welcome to this video where I'll explain the simulation of charging a battery using a buck converter powered by photovoltaic system with maximum power point tracking. Let's dive into how this system works and its key component. We are simulating a battery charging system powered by a solar panel using a buck converter. The goal is to extract the maximum power from the solar panel and use it to efficiently charge the battery. Here's a quick rundown of the main components.
However, the power output from a PV array is highly variable depending on factors such as sunlight intensity, irradiance, ambient temperature. This variability makes it challenging to operate the PV array at its temperature, maximum efficiency at all times. To address this issue, maximum power point tracking algorithms are used to optimize the power output from the PV array. MPPT continuously adjusts the operating voltage and current of the PV panel to track the point where the panel produces the highest power, known as the maximum power point. This ensures that regardless of changing environmental conditions, the solar panel generates the most power possible. The MPPT controller calculates the optimal operating point and sends a signal to control the power electronics, typically a DC to DC converter. In this system, a buck converter, which is a step-down DC to DC converter, is used to regulate the voltage from a PV array and match it with the voltage requirements of the battery. The buck converter reduces the higher voltage from the PV array to the lower voltage needed to charge the battery, ensuring efficient power transfer. The MPPT controller adjusts the duty cycle of the buck converter switching device, which could be an IGBT and MOSFET, to ensure the converter maintains the PV panel at the maximum power point. The duty cycle refers to the proportion of time that the converter switch is on, and it directly controls the output voltage of the buck converter by varying the duty cycle based on real-time feedback.
Now let's see the block diagram. This block diagram shows a simple solar power system where energy from the sun is used to charge a battery and power other device. First, PV panel means solar panel. The solar panel takes sunlight and turns into the electricity. It produces current, how much electricity flows, and voltage, the strength of the electricity. Second, DC boost converter. The boost converter increases the voltage from the solar panel to a higher level that the battery needs to charge. It adjusts the electricity to make sure it is just right for the battery. MPPT controller, maximum power tracking point. The MPPT controller ensures the solar panel works it is best, getting the most power possible from the sunlight. It measures the voltage and current from the solar panel and adjusts the boost converter to maximize the energy going to the battery.
Hello, to simulate the solar PV system with a boost converter and MPPT in MATLAB, follow the steps in a step-by-step. First is create the solar PV array. Use the PV array block in Simulink to the model the solar panel. Set a radiance and the temperature parameters in the input to the blocks. Second is design the boost converters, inductors. Place an inductor between the input PV array and the output battery, which IGBT of or MOSFET. Use a controller which boosting with the voltage diode. Place and the diode to allow current to flow in a one direction. Capacitor. Add a capacitor at the output or smooth the voltage. Use a PWM generator blocks to control the duty cycle of the switch based on the MPPT control. Third is MPPT control design. Use the perturbs and observe the piano or a incremental conductance in con algorithms. Measure the PV voltage and PV current from the solar panel. Calculate the maximum power point and generate the appropriate duty cycle for the boost converter. And fourth is the battery model. Use the battery blocks and Simulink SimSpace toolbox to model the battery. Connect to the output of the boost converter. Monitoring of the battery voltage, current and state of charge SOC. Fifth is loads. Add a similar converters load or use an appropriate blocks to present other device that will draw power from the battery. 6 is connect the system. Connect the PV array output to the input of the boost converter. Use the MPPT control to adjust the duty cycle of the boost converter. The output of the boost converter should be connected to the battery of the charging. The load can be connected to the battery in simulation energy use. The MPPT uses a perturb and observe algorithm. It works by the slightly perturbing the voltage or current and observing the change in power. If the power increase the content in that direction until it reaches the MPPT. This ensures that the system operates at the optical point of the maximum in the energy extracted from the solar panel, and the buck converter step down the high voltage from the PV panel to match the charging voltage required by the battery. In simple terms, in the reduce the voltage while increasing the current. This is a critical silence, and the voltage can only handle a specific voltage range is set the charging the buck converter using the pulse width modulation PWM to control the match switching its component and adjust the output voltage accordingly.
Now let's look at the actual simulation setup. The PV panel is connected to the buck converter, which in turn is connected to the battery. The MPPT controller adjusts the duty cycle of a buck converter based on the input from the PV panel, ensuring that the battery charges efficiently. In the result, you can see how the battery's state of charge increase at its charge by the PV system. The buck converter maintains the appropriate voltage and control level, while the MPPT ensures maximum power in extraction from the PV panel. The graph demonstrates how output adjusts dynamically based on the changes in sunlight. Using PMPT with a buck converter has several advantages. First is efficiency. Maximum power extraction from PV panel leads to the faster and more efficient charging. Battery protection. The buck converter ensures that the battery is charged with the correct voltage, preventing overcharging or damage. Dynamic response. The system can adapt to charging weather condition, ensuring optimal operation throughout the 7 is a simulation parameter. Set a simulation time based on a scale of your system such as 100 seconds. Use a district solar like ODE with a suitable example. 1E minus 6 seconds. Simulation blocks requires the PV array, boost converter components like inductor, capacitor, diode, MOSFET and IGBT. MPPT controller logic can be created with a simple block or MATLAB function. Battery, space, electrical load, resistive or capacitive with a constant load. Display scope of usualize output like a voltage control. Step to the set up a simulation model. First is a PV array block. Drag and configure the PV array block for the irradiance and temperature. Second is a boost converter. We use space electrical blocks for the inductor, switch, IGBT diode and capacitor. Use a PWM block to drive the MOSFET with duty cycle from MPPT controller. MPPT algorithm. Create a MPPT algorithm using logic block or MATLAB function to adjust the duty cycle for a boost converter. Use a perturbs and observe the method for track the maximum power point by the adjusting the duty cycle. Fourth is a battery. Configure the battery block to the store energy from the boost converter output. Monitor key parameter like a voltage control and SOC. Fifth is a simulation and the analysis. Run the simulation. Observe output like a PV power, battery voltage, current and SOC on scope or display. Adjust the parameter of a boost converter MPPT as needed for the optimal performance. This setup will allow you to simulate a complete solar PV battery charging system with a boost converter and MPPT in MATLAB. Thank you. Or MATLAB function to adjust the duty cycle for a boost converter. Use a perturbs and observe the method for track the maximum power point by the adjusting the duty cycle. Fourth is a battery. Configure the battery block to the store energy from the boost converter output. Monitor key parameter like a voltage control and SOC. Fifth is a simulation and the analysis. Run the simulation, observe output like a PV power, battery voltage, current and SOC on scope or display. Adjust the parameter of a boost converter MPPT as needed for the optimal performance. This setup will allow you to simulate a complete solar PV battery charging system with a boost converter and MPPT in MATLAB. Thank you.
In this system, a buck converter, which is step-down DC converter, is used to regulate the voltage from the PV array and match it with the voltage requirement of the battery. The buck converter reduces the higher voltage from the PV array to the lower voltage needed to the charger of the battery, ensuring efficient power transfer. The MPPT controller adjusts the duty cycle of the buck converter switching device, which could be an IGBT or MOSFET. To ensure the converter maintains the PV panel at the maximum power point. The duty cycle refers to the proportion of the time that the converter switch is on and the directly controls the output voltage of the buck converter by varying the duty cycle based on the real-time feedback from the PV array. The converter ensures that the PV panel operates at its most efficient point and the energy extracted from the panel is efficiently transferred to the battery. The battery module play a crucial role in the storing the energy generated by the solar PV system. Batteries act as the energy store device, ensure the excess energy generated during peak sunlight hours can be stored and used when sunlight is unavailable, such as during night time or cloudy condition. The charging process involves monitoring the battery voltage, charging current and state the charges SOC to ensure the battery is charged safely and efficiently. Overcharging or undercharging a battery can significantly reduce its lifespan. So accurate control of the charging parameter is essential. In this setup, the MPPT controller, buck converter and battery work together in harmony to create an efficient solar power battery charging system. The real-time monitoring of a key parameters such as voltage, current and SOC ensure that the system operates reliably and delivers sustainable energy. The combination of solar PV, MPPT and a buck converter allows for optimal energy extraction. In conclusion, this simulation demonstrates how a PV panel with MPPT and a buck converter can effectively charge a battery. The combination of these components ensure optical power transfer and safe battery charging. Thank you for watching. I hope this explanation helped you understand this simulation. Thank you so much.